I think when you like started to say hi, which is
Hi, can you hear me okay? I know I have a quiet voice and I also tend to like drift. So if you can't hear me at some point, please just let me know, okay? So my name is Emily Neuhaus, and I'm sure that is not like the authentic way to pronounce my last name, but that's the one that I got. So, so that's fine. I'm here from the University of Washington with the DYRK study. And so for context, I'm an assistant professor in the Department of Psychiatry and Behavioral Sciences at the University of Washington, but I'm a clinical psychologist by training. And so what that means is that I'm not coming to this work today as somebody who has background in genetics or biology in particular. I'm coming as a psychologist, so somebody who has worked directly with families, who specializes in diagnosis of autism and neurodevelopmental conditions. And I spend my time both doing research and working directly with families at the Autism Center at Seattle Children's and do diagnostic evaluations with families every week to help them figure out if autism is a part of the picture for them. Sometimes I'm seeing kids who have really complex genetic and medical histories, and sometimes I'm not. So it's a whole range and a whole variety of ages and families. And thank you so much for having me. In terms of funding and disclosures, my research right now is funded through NIMH and also through Safari Spark. So I direct the Seattle site for the Spark network. We are kind of got the northwest region of the country right now, so happy to answer questions about any of that. So in the time I have today, my hope is to tell you some about the DYRK study. I think it's going to sound super familiar to some people here, and it's going to sound totally new or maybe vaguely familiar to other people. So I'll tell you a bit about that. And then I want to spend most of the time talking about what I'm focusing on right now from what we're learning about the DYRK study, right? Because it's got a ton of information, publications out from it over the years. But I want to tell you about what I'm thinking about now. And then finally, I want to talk for a few minutes about where I'd like to see the DYRK study going moving forward, including talking about something called STRIPES, which is sort of an offshoot next step. So the DYRK study at the university has been going on for over 10 years, and it is led by Evan Eichler in UW Genome Sciences. And then, so he directs the genomic genetic side of things, and his team, they work with enormous data sets, do extremely complex things. And then this other side that starts with Raphael Bernier and then Rachel Arnold and then myself, we're the behavioral side of things. Okay? And so originally this study started as a collaboration between Dr. Eichler and Bernier, and then as Dr. Bernier stepped off, Dr. Arnold moved into that spot, and then as she stepped off, it's with me. So I continue to work really closely with Dr. Eichler. His group tends to say these are genes that our analyses show us are really important for neurodevelopment. And then my team is responsible for going out and finding families who are affected by those variants to say, okay, what does that really look like when we talk about real people, real kids, real families? What do we see? So DYRK follows what's called a genetics first approach. And so if you look at that first side with the question marks, we've known for a long time that there are links between genetics and behavior. And so one approach to that is to start with the behavior, like autism, for example, and to say, okay, we think some genes are involved. What genes are those, right? And to try to go in that direction. But DYRK goes in the other direction. It starts with the genes, so DYRK1A in this case, and it says, okay, we know that something is going on with DYRK1A for this group. What are we seeing in terms of medical complications? What are we seeing in terms of neurodevelopmental or behavioral features? What are we seeing in terms of mental health? Right? So we're going the other way, where the thing that's in common is the genetic basis, right? All right, so it's been going for a long time, and the DYRK study has evolved and changed over the years. So it used to be that families would come in person, they would spend a couple of days with the lab, they would do a whole bunch of different evaluations, diagnostic evaluations, measures of IQ, medical exams, blood samples, EEG, lots of things, right? And that gave a tremendous amount of really rich data, but it also meant that families were coming to us, which is, we're in the corner of the country, right? We're not exactly like a simple flight for most people. So it gave us a ton of data. We got to really work closely with families, but it's hard. So now we have a fully virtual and remote model. So what that means is that families don't come to us. We use Zoom calls, phone calls, online questionnaires. It means that families can stay home, continue on with their work schedules, their therapy schedules, their school, their childcare, all of those things. And it means that families can fill out surveys in the middle of the night if it really wants to. Okay? I don't recommend this, but whatever works for you is super. It also means that we can enroll families across a broader range, right? So we can have families all over the US, and we can have international families. So one day I talked to somebody who was hours ahead of me in time zones, and then later I talked to somebody who was hours behind me in time zones. I mean, it was kind of a trip, but it was pretty cool. And so we're still able to do a lot of direct evaluations over Zoom, where we can measure different skills, and then we've got a lot of caregiver interviews where we're relying on parents and family members to really tell us a lot. And then we've got surveys where we have really standardized, established tools. We are still enrolling, so we are enrolling across 10 gene groups. DYRK1A, I think, might be our biggest group, so we have the most. And as we get more, obviously, right? So feel free to get in touch if you would like to. So why is DYRK1A part of the TIGER study? So originally, the goal was to learn about genes that might be contributing to autism, right? When this all started in 2012, 2013. And so you can see here some of the papers that involve it that were really saying across these really big samples, really complicated analyses, that DYRK1A is popping out as one of the most robustly associated single gene causes of autism. So among people with autism who have one gene that seems to be causing it, DYRK1A is one of the most common ones, the most strongly connected. But we certainly know that it's not just autism, right? I think everybody in here is probably more of an expert than I am on the constellation of features that DYRK1A syndrome can bring, right? These are just some of the most, sort of the highest frequency as documented in the literature, right? Spans all sorts of systems in the body, beyond the brain, GIs for hearing, sleep, feeding, cardiac, lots of systems. And then when we look at sort of the behavioral side of things, we can also see that there are some pretty broad effects, but then it's also kind of cloudy to understand what those are, right? So this is from a paper from 2017, that was documenting the frequency of these different pieces. And so I've highlighted, you can see 98% of the folks they found in the literature had intellectual disability or a global developmental delay. 100% had speech delays or motor difficulties. If you look at the bottom section that I've highlighted, 46% had autism. But higher rates than that have stereotypic behaviors, which can be part of autism. And high rates of behavioral differences, right? Like, what exactly does that mean? And why are the numbers so different across all our different evaluations? Some of that is because, these data are coming in part from review of medical records, and we don't always know if things were counted in a medical record, right? If something doesn't say that somebody has autism, does that mean that they don't? Or does it mean that the doctor didn't ask that question? Does it mean that nobody checked? So we get really different numbers, right, depending on the source of the data and what we're thinking about. Are we thinking about a full formal autism diagnosis, or are we thinking about some features of autism, right? So it's cloudy. So my goal with TIGER is to try to unpack some of that cloudiness and to say, here is what we're learning about some really key areas. So what I've been focused on now, what I'm going to tell you about today, is some of our information about early development, thinking about intellectual and adaptive skills, right? Those are the components of intellectual disability. Thinking some about autism, and then thinking about mental health, which I think is a pretty new kind of addition to understanding the phenotype of DYRK1A syndrome. And I forgot to say, please interrupt me anytime. That's totally fine. Just have your hand up, okay? All right, so the data that I'm sharing today are coming from 29 individuals with disruptive variants to DYRK1A in the entire study. And these were identified when families share their genetic reports with us that they've had through clinical care, and we can review those, and Dr. Eichler's team can look at them and say, yes, this is a variant we would consider to be disruptive. Our sample is slightly more male than female today. It's not too far off from a 50-50 split, though, which I think is uncommon when we think about neurodevelopmental conditions. So I like that we have reasonable representation across those two groups. In terms of ages, we're spanning from the early childhood up through early adulthood. So the youngest kid is 4 and the oldest is 22, and the average here is about 10. So what I'm talking about today is really childhood and adolescence and those teenage years and a bit of early adulthood, but I don't have data to share today on adulthood or later adulthood, which I think is a really important component, right? As kids become adults. So we'd love to learn about this.
You said this was from 2017?
No, these are our current data. So that earlier table that I showed you was from 2017, and that was a combination of tighter data plus literature, who was counted out there. This now is specifically families we've seen in tighter. Yeah. So certainly, people, older folks have been documented, just they're not in this data set today. Thanks for that question. Okay, so let's think first about early development. So I had, shown you that list that said that early delays are really common, right? But what does that look like? So one of the things that we can sort of describe pretty concretely is when folks start to walk independently, right? Like families usually remember that well, it's in medical records. And so when we ask that of our DYRK1A families, we find that 93% of individuals had met that developmental milestone by the time that was saw them. And on average, they were meeting that milestone around 23 months. So you can see, I don't know if you can see this sort of graph at the bottom, but that's a distribution of the ages, and the age in months is along the bottom. So you can see that there's a lot of range there, but the average is it's just before 2 years, right? And if you consider the general population, that's typically around 18 months, right? 12, 15, 18 months that we think about kids walking. So there's definitely a delay there. We can also think about communication development. And so when kids are beginning to use single words, right, and this isn't mom or dad, this is something like ball or cat or shoe or no, right? It's a word that a child first uses in a meaningful way. So this is something that 2/3 of our sample, of our group, had attained by the time that this was done. And on average, that was coming on around 41 months. So that's around 3.5 years of age, right? That first single word was happening. And again, that's a milestone that we think of as around 18 months for the general population. So you can see that that's delayed and maybe even more delayed than that motor development, right? Communication might be more delayed. When we think about a next language development, we think about phrases. This is when kids start to put together 2 or 3 words at a time to tell us something slightly longer. So fewer than half of our families told us that they had met this milestone. But when they had, the average tended to be around 53 months. So it's about 4.5, right? So what I think you can see is that we've got this pattern of broad delays. It could be that communication delays are more effective than motor delays. And it could be that the magnitude of that delay is kind of growing as we move further in this development, right? So it's on its kind of own curve. As kids get older, we start to be able to measure things like IQ, right? So we can start to talk about their cognitive or intellectual skills rather than just thinking about delays, right? Sometimes delays are there for a bit and then they sort of resolve or change. But as kids get older, we can start to get more kind of concrete information that tends to be true for them longer term. So if you take the 29 individuals with DYRK1A syndrome and we kind of think about where they fall in terms of intellectual ability or disability, this is what our distribution is looking like. So in that lightest wedge, you can see 10% of folks who did not have an intellectual disability. So that tells us that that reflects the fact that their IQ is in the average range or higher. We do have folks like that. And that we have, or that they are maybe in sort of the below average range, but it's not sort of meeting the threshold for a diagnosis of an intellectual disability. You can see we have a big chunk of folks in this unspecified group, and those are probably our younger kids who we're still talking about delays, and we're not yet talking about whether they have an intellectual disability. They're just not at the age where we would say that yet. And then after that, you can see that we have folks in every sort of wedge here, right? Every segment has a solid number of people. We see this whole distribution, a whole range of ability in our DYRK1A families, right? It's not a cluster in just one wedge, but there is a lot of variability there. If we look at actual IQ scores, what I'll sort of point out to you is that the yellow box is verbal IQ. So think about language-based intellectual skills, like knowing vocabulary, using words to reason through things. And then the blue is nonverbal. So that's like visual spatial skills, puzzles, problem solving. And what I want to point out too is that, again, that those boxes are big, meaning that there's a lot of range in those scores, and that they're pretty even with each other, like going across. So we're not seeing that folks tend to be really strong in one and really weak in the other, or vice versa. And that's a little bit different than some neurodevelopmental conditions, right? Where we might see a big split in different areas of skill. For DYRK1A families, we're seeing that these are pretty comparably developed. So adaptive behavior, is that a familiar term to folks, or is that a new one? Familiar? A little bit? Okay. So this is not IQ, but we often measure them together because this is your real life skills. So IQ is what we can measure in a really standardized way and you get a number. Adaptive behavior is what you can do in your everyday life, what you do, right? Maybe you can solve a puzzle or an IQ test, but this is about, can you navigate somewhere in your daily life, right? Can you care for your body? Can you interact with the people around you? Can you participate in your daily life? And so it's really important, right? It has a big impact on quality of life. And we often measure that through the Vineland adaptive behavior skills, and it gives us a sense of communication skills, daily living skills, and socialization skills. And so what I'll show you again here is that we see a lot of variability within our groups across all three of those. And we see that those skills are pretty evenly developed. So the sort of the averages in the groups are pretty similar across these three skills, telling us that those skills are developing pretty much in concert, just like we would expect. If we think next about autism, we can do that in a few different ways. And so I know some of us here may have spent a lot of time reading and learning about autism, and so this might be redundant for them, but other folks, this might be totally new. And so I just want to say, when we're talking about autism, this is the formal kind of diagnostic picture. This is what we're looking at. We have two big areas of skills, so social communication and social interaction, and then restricted repetitive patterns of behaviors, interests, or activities. Those are our two big domains. And each of those is made up of smaller domains on the sides there. So you can see that there's a lot of different components to that. And so that means that it is not always straightforward to figure out if someone has autism. And it can mean that one person with autism can look really different from somebody else with autism. They can have a different constellation here and still kind of get that same descriptive term, right? So if we think about the rates of autism in our DYRK1A group by asking families about that history, what it basically saying, does your child have autism? They tell us that about 60% of the time, yes, we do, my child does have autism, and about a third of the time they tell us no. So that's pretty high rate, right, 59%. On average, folks who have that diagnosis got it around 5 years, and that is slightly older than the average of the general autism population. It's not hugely outside of the window, though. However, at the end of the study, when we have really good data and assessments, and we say, okay, does this person meet diagnostic criteria for autism? We actually find that 83% of the time the answer is yes. So that's even higher, right, than 59%. And so this, this could be due to a lot of things. It could be that nobody has said, have you considered autism for your child? It could be that somebody has said that and a family has said, it's just not our priority right now. It's not what we want to do. It's not where we're going to put our time. It could be that a family has said, I want to, but I don't want to do that, or my insurance doesn't do it, or I'm on a waiting list, right? It could be lots of things. But what it means in my mind is that that's about 25% of our group who could be having access to autism-related services if they have a diagnosis, and who likely are not. Okay. So we move beyond a formal diagnosis and we think about sort of symptoms and features. But ADOS, Autism Diagnostic Observation Schedule, is like one of our very main tools, and this might sound familiar to folks. It's like 45 minutes, play-based assessment in a clinic usually with a psychologist or another clinician. And he gives us a sense of symptoms both in that social side that I was talking about and in that repetitive behavior side. And so I'm just plotting these here to show you that, again, both of those areas are affected in DYRK1A. both of them are well above that diagnostic threshold of that dashed line. But again, there's variability, right? So those purple boxes are tall, and those sort of light branches that come out from them are even taller. Those are the distributions of groups. We've got lots of variability. Based on this sample size, we don't, sort of like the statistics don't show us that there's a difference in severity between the social skills and those social features and the repetitive features. So you can see the boxes do look a little different. So as our group gets bigger, I hope we're going to learn more about whether autism itself is different in DYRK1A. This is another way to measure some of those pieces that are related to autism. This is a parent questionnaire called social responsiveness scales. That's something like 65 different questions on it. Parents who rate their child's behavior, and we get a sense of what kind of difficulties they might have in terms of social awareness, social cognition, social communication, social motivation, and then that last one, manners, is sort of repetitive. And so what I want to point out to you is that there's this box here, social motivation, that is different from the rest, right? It stands out statistically, it's different from the rest. And this is an area that's closer to the average for the general population. So this is an area that seems to be less effective in DYRK1A, right? So I was running these data and putting this together. And then last night I was here watching the kids running around, talking to each other, talking to me, asking questions, showing off their talents. And I was like, there it is, right? Like that's a strength right there, which is pretty cool. And so what I like about this is that it's a strength to build on, right, for other kinds of skills that you may want to pursue for your child. And it's a potential way to say how DYRK1A might be different from other conditions associated with autism, right? Like there are unique things about it, and this could be one of them. Okay, so let's think about mental health. So we know that DYRK1A is associated with autism. We know that autism is associated with a higher likelihood of mental health. So if you look at that purple, the purple bubbles over there, there are estimates that up to 70% of people with autism have a psychiatric condition as well. And that's just thinking about a diagnosis. So if you just think about symptoms or features, it could be even higher, right? And some of the most common there are ADHD, anxiety, depression, behavioral things like challenging or aggressive behavior. But we don't know what all of that looks like in DYRK1A, right? Like that graph or that sort of chart I showed you at the very beginning said like behavioral features, behavioral difficulties, right? But what is that? So we can start to find that out. So one method to ask that is, again, to go to medical history and say to parents, okay, which of these conditions has your medical team diagnosed or identified for your child, right? I think of this as like a real world one, right? Like what do families have on their radar as something to be watching for, or treating, or supporting, right? So the rates are pretty low here. So 7% of families said ADHD, 11% said anxiety, 17% said PICA, that's eating things that aren't food, right? And 3% said Tourette's, 3% said OD, which is oppositional defiance, which I don't love as a diagnosis, but it exists. And then if you can read that last line, it says that there were no reports of depression, bipolar disorder, psychotic disorder, obsessive compulsive disorder, or PTSD. And to some extent that makes sense, right? We're talking about relatively young folks who can expect really high rates of those things anyway, but I do just want to point that out. So in addition to thinking about caregivers and family medical history, we can ask caregivers to fill out questionnaires that tell us about symptoms in these different areas. So this one might look familiar to folks. It's called the Child Behavior Checklist. There's also the Adult Behavior Checklist, like 120 items where you would rate whether each statement was not true, somewhat, or sometimes true, or very true. And then we can get scores on things like anxiety, depression, ADHD, behavior. And we can quantify those scores as to whether they're in the average range, sort of a borderline range, where they're starting to get elevated, or a clinical range, where they're up there and really produce this score, right?
What's the difference between the adult and child?
Pardon?
What's the difference between the adult and the child?
Oh, it's just the age range that it would be asked with.
Considered 18.1?
Yeah, so the child is 6 to 18, and the adult would be 18 plus. There are also self-report versions, so you might include plus question, but yeah, that's about 18. Okay, So what I've done here is plotted the averages across those 4 domains: depression, anxiety, ADHD, and oppositional. And so keep in mind, these are like symptom scores, right? This doesn't mean that folks have that diagnosis. It means, or that they should have it, right? It means that they have elevated symptoms potentially. And so this bottom line right here, this is 50, so that's the average of the general population. And then this upper dashed line is when folks are crossing over into that sort of borderline or clinical range that's more problematic for them. You can see those sort of turquoise bars move around, right? And so it's depressive symptoms and ADHD symptoms that appear to be higher in this group. And they're statistically higher than the anxiety and oppositional behavior. So that's telling us that those are potentially more likely to be problematic areas for DYRK1A, right? Depression and ADHD. We can also plot out the percentage of folks in our group who have scores that fall into the average range in the lighter purple, or scores that fall into that elevated range in the darker purple. Again, you can see that with depression, 60% of our families, the scores were in the average range. But that means 40% of our families, those depressive symptom scores are falling in an elevated area, right? ADHD, it's about 50-50, right? Half in the average range and half in an elevated range. And I think this is interesting to look at the ranges in addition to just the scores, because you can have a higher score on one thing than another. It doesn't mean it's causing you any problems, right? You can have 2 scores that are different but still average. But this is showing us that actually it's in an elevated range that could use some support potentially. So I also think it's interesting to think about how all of that sort of gets distributed. So we know that there are elevations in different areas. Is it that everybody's got sort of some difficulties in some area, or is it that there are some folks who are really experiencing a lot of difficulty across the board? So what I've done here is just added up the number of those 4 subscales for each person that's elevated. So this tallest bar, that is 0. That means that for 10 of our families, so a third of our sample, there were no elevated ranges, right? All of those behavioral scores were in the average range, right? That's great. It also tells us here, though, that 10% of our group has a score of 4 here. That means that across all 4 of those areas, their scores were in that elevated range. So we have families here where mental health is just really not something that they're contending with probably right now. And then we have families where that's problematic, and it's problematic in more than one way. And then finally, this is sort of a visual way to understand how that overlap is working, right? So it's a Venn diagram, which is hard to make with 4 groups. It turns out it takes some Googling. But what it's telling us is that all of the numbers that are in each of those ovals, those are the elevated folks for that subscale. So for example, this 4 right up here, that's under ADHD, there are 4 families who had difficulties with ADHD symptoms only, right? It doesn't overlap with anything. With depression, that means there's 3 families who are having difficulties with depressive symptoms only, right? And then if you look here, that's where all 4 of those ovals overlap. Those are our 3 folks who have difficulties in all 4 of these areas, especially, right? So we know it's like a little quirky to interpret, but the take-home messages from this, there are 2 of them. One is that we don't see anybody who has only anxiety or only oppositional behavior, right? Those things were elevated only when other things were also elevated. So those don't seem to come alone, right? Whereas depressive symptoms and ADHD symptoms potentially do come alone, right? The other thing that I'll point out is that we have that 3 over there in depressive. But if you think back to the medical history I told you about, no families told us that depression was on the radar. Nobody said, yes, my child has a diagnosis of depression, or that's something that our team is thinking about. And, we can't say that they should be, right? This is, I don't know those families right now to do a diagnostic interview with them, but the potential is there that these are missed mental health diagnoses that need to be picked up and hadn't been in the course of routine clinical care. So what do we take from all this? So first, those developmental delays are very common, right? That's what the literature tells us, and that's what our data say, and it may be especially true in communication. Intellectual disability is also really common, but it spans that full range, right? From absent to mild, all the way to profound, right? We've got everybody represented on that picture. Rates of autism are high and are even higher if we think about them after a standardized rigorous evaluation, like the one included in DYRK. And there may be some variability in what that autism looks like, right? That social motivation is a strength, or some, sort of differences in the constellation of symptoms. But the fact that there may be a number of families who are missing an autism diagnosis that is appropriate for them, that, in my mind, is a problem for access to behavioral supports and services. So this paper that I've cited here is one that has just come out from my group, led by a graduate student, and she found that when we used a variety of factors to predict access to different treatments, having an autism diagnosis was a big predictor of being able to access behavioral therapies like ABA, applied behavior analysis. So this matters, right? Okay, so we're both autism and mental health, we're seeing differences between caregivers' concerns or what caregivers tell us through medical records and what they tell us through standardized assessments. And this can be for two reasons. One is that we may be missing mental health concerns, right, through something called diagnostic overshadowing. And that's a phenomenon where once somebody has one diagnosis, their team starts attributing other difficulties that they have to that one diagnosis, right? Like, well, you've got autism, so, right, it's hard for you to pay attention, that's your autism. But maybe it's actually ADHD also, right? And this matters because sometimes that thing we're missing is something we can treat, or it's something we can use to understand or to communicate to teachers or child care providers something helpful about our child. It could also be that those higher scores on depression and ADHD are coming from symptoms that are part of DYRK1A's like physical manifestations rather than actually needing depression or ADHD, right? We don't know. But for an example is that when we're diagnosing depression, we think about sleep, right? Like, are you staying restful? Are you fatigued during the day? Are you waking up too early? Can you get to sleep? And for the general population, those can be indicators of depression. But for folks with DYRK1A or other rare genetic conditions, maybe it's part of the like direct effects of the gene. We don't know. It could be true. Our data, we just don't have the data right now to know that. So it's important. Yes. So, do you want the microphone?
I think I'm okay. The Theo just got diagnosed with CVI, 23, when he was 20. When he was younger, he would be in a new cortical visual impairment. So that means that what he sees gets to his brain slower than what you and I see. And it also has other visual. But when he was younger, he would be in space the first time, and he would be up and about, looking and walking. It seemed like impulsive behavior. But I think he really couldn't see well. Within the space again, he couldn't see well. So that's another example of another diagnosis creating behavior, and we think, oh, we have to address the behavior, really have to address the vision.
That's such a great example. That's such a great example. Well, it reminds me of kids that I see for an autism diagnosis, and we need to know if their hearing is tested, right? Because maybe they're not responding to their name, but why? Maybe they're not hearing us, right? Yeah. Thank you for that. Okay, and so that also, suggests that our rating skills are not perfect for this population, right? Like they were developed in the general population. We probably need some adaptation to work their best here. But sort of my overall recommendation from all of this is that we should have standardized screenings for autism and mental health that are appropriate to the DYRK1A population, and they should be integrated as part of routine clinical care, right? So in terms of where we're going with DYRK, we are continuing to enroll and invite families, no pressure. But as we get a larger group, we can represent the population more equitably and more accurately. And as we have more people, we can start to look at the connections within it. So for example, we can look at how some medical conditions might be related to behavioral conditions. Or we can look at how early developmental milestones might predict later outcomes, right? We need numbers of families to be able to do those types of analysis. we also can begin to look at sex differences, right? We know that autism and other neurodevelopmental conditions often have differences in males and females, but we don't know that yet for DYRK1A. I also have a lot of interest in thinking about developmental trajectories over time, right? And this is because it helps us predict later outcomes and understand adulthood, which I touched on earlier. And it helps us make recommendations for screening and support. And so we can do this in part through actual longitudinal research, right, where we're following families over time and we really got that data. But we can also sort of exploring ways that we might be able to use existing data in new ways, right, to look backwards in someone's development and say, okay, there are forms of data that exist for them. How can we find that? How can we harness it? How can we use it to understand development before we knew that we needed to understand development? Makes sense. And then a final about sort of how specific all of this is to DYRK1A, right? So this is a paper that my group published a couple of months ago where we were looking at mental health features across 3 different rare genetic conditions associated with autism, so that we can begin to pull out sort of the profiles that are specific, right? And that's important because we want to know about DYRK1A specifically, right? That's the one that matters to people sitting in this room. And when you're at the doctor with your child, that's the one you want to know about. And so again, as we get our bigger numbers in the entire study, we can begin to do more of this. So, I said I was going to talk about stripes, which is the study of research interests, priorities, and experiences. And I'll just tell you that tiger is a hard acronym to follow, but stripes feels like a pretty good one to go along with tiger. So the goal here is to complement what my team as researchers and clinicians think should be the priorities for research moving forward, to complement that with what folks in this room think, right? And so what this is a new study that I just launched, actually. And you can, if you're interested, you can go to the QR code or the link, and I also have flyers that I'm happy to hand out. But it is asking about sort of your interest and connection to the rare gene community, and seeing if there's a particular gene that you're connected to. And then it asks what your priorities are. There's like some open-ended questions where you can tell us anything that you think we should know. And then there's some specific priorities based on the literature and our experiences and other family conversations where you can rate them and tell us so that we can really figure out where should we be focusing our time and our energy in a way that's going to be most useful. Okay, so some thank yous. So this is a snippet of the folks who have worked on Tiger over the years. And then I also have a very big thank you to all of the families who have participated and contributed a lot of their time to the Tiger study. It's an investment, right, for sure. And then I want to thank all of you for listening and for your anecdotes and your feedback. And I'd love to hear more thoughts and take any questions. So thank you.